Okay, it started. All right. Hello, class. Lesson 11, group problems. Caleb and Haley, here we are. And we're going to start with question number 1. So this question concerns the molecules involved in translation. So for number 1, A, it asks us to indicate a group of enzymes that covalently link a tRNA molecule to the amino acid, and that's amino acyl tRNA synthetasis, yeah, whatever that is. And then B, 4 proteins that consume GTP. So IF3, IF2, EFTU, and then EFG are all proteins. They're 4 proteins that consume GTP during translation. I don't know if you can see any of my answers, but and then C, 1 molecule that functions as a ribozyme during translation. And this one is the peptidyl transferase. And then D, 2 proteins that recognize stop codons. This is release factor 1 and release factor 2. And then E, 1 molecule that forms hydrogen bonds with the Shine-Dalgarno sequence in the mRNA. That is portions of the 16S rRNA. And then, question number 2.
All right, so pretty straightforward again, fill in the blanks. It's all from the notes. So for A, the first amino acid in prokaryotic proteins is methionine, because that's always the start codon. An E. coli protein called, and then it's going to be EFTU, delivers charged tRNAs to the A site of the ribosome. And for C, the initiator tRNA binds to the P site of the ribosome, whereas the remaining charged tRNAs bind to the A site of the ribosome. And so D, EFG, is going to be the translation factor that helps the ribosome move 1 codon in the 3' direction. And then E, IF3, is a translation factor that guides the mRNA. So F, the AUG codon, is the start codon, while UGA is an example of a stop codon. And there were also other examples of stop codons in the notes as well. So for G, degenerate is a term that indicates that more than 1 codon can specify the same amino acid. And H, the final amino acid, is located at the C terminus of the polypeptide.
Perfect. Okay, question 3. This is a series of mRNA codons, and we're considering the wobble rule. And we're supposed to provide all the possible tRNA anticodon sequences that can form hydrogen bonds with each mRNA codon. So for A, it can form, and then this is, since it's the anticodon, it's 3' and then 3 to 5' instead of 5 to 3. And so A, in order to match with the UUG, you can have AAU or AAC. B, in order to match with AGU, you can have UCU, UCG, UCC, or UCA. And notice that in all of those, the first 2 bases are UC, because the wobble rule just has to do with the third base in the sequence of the codon. Or there's a wobble rule. That's what the wobble rule means. So with C, UAC can match with AUG, the 3' to 5' AUG. D, it's AUU, and so the 3' can do UAA, for D, it can do UAA, UAG, UAC, or UAU. And then E, for GCA, you could do CGA, CGU, CGG, or CGC. So that's question 3. Then 4, this deals with E. coli. It contains a protein called protein X, and it's 218 kilodaltons in molecular weight. So if the average amino acid is 125 daltons, how many amino acids are found in protein X? So first, you convert kilodaltons to regular daltons, and that's 218,000 daltons total. So the average amino acid is 125 daltons. And the average, I'm sorry, I'm reading this question. Oh, how many amino acids? Okay, so you take 218,000 and divide it by 125 daltons, because that's how many amino the amino acid is, and you get 1,744 amino acids. So that's the average amino acid in protein X. And then B, what is the length of the mRNA coding region? The length is, you would just multiply 1,744, you multiply that by 3, because there's 3 base pairs per each. And so the length is 5,232 base pairs. That's the mRNA region. And then how many GTP molecules are consumed to synthesize each copy of protein X? So if there's 3 GTP molecules that are consumed in synthesizing, or the elongation process of making protein X, then you just multiply 5,232 base pairs. I'm sorry, I'm reading this question one more time. How many GTP are consumed to synthesize each copy? Or no? Okay, yeah, and so you take 5,232 and multiply that by 3. And I did it wrong on here. And so the answer would be 5,232 times 3. It'd be 15,696. And then D, how many ATP molecules are consumed to synthesize each copy of protein X? So ATP, it uses 1 ATP molecule per codon. And so there would be 5,232 ATP molecules used. And then what is the name of the group of enzymes that consumes ATP to assist in the synthesis of protein X? So amino acid tRNA synthetases is the name of the group of enzymes that consumes ATP. Yeah, there's question 4.
All right, so for number 5, again, all the answers are found in the notes. So for A, which of the above is involved in translation initiation? And it's going to be IF3, IF2, and then tRNA F-MET. And for B, which of the above is involved in the translation elongation? And it's going to be 16S rRNA, and then 23S rRNA, and then EFTU and EFG. So for C, which is involved in translation termination, it's going to be RF1. And then D, which is a component of the 70S ribosome, and that's going to be 23S rRNA. So E, which of the above is found within the mRNA? So it's going to be the Shine-Dalgarno sequence, and then the 3' AUG, which is the start, and then the 5' to 3' UGA, which is the stop codon.
Sweet. Well, that is all of our questions for today. Hopefully that helps in some way. So, yep, have a good weekend.